All right, the kerogens are made of keratins, and the keratin is a family of fibrous structural proteins. Those are the fibers. Anyway, keratin is the key structural material making up the outer layer of human skin. It isolates you. It's also the key structural component of hair and nails and so forth. Keratin monomers assemble into bundles to form intermediate filaments. And they're tough, and they form strong, unmineralized tissue found in reptiles, birds, and mammals. The only other biological matter known to approximate the toughness of keratin tissue is chitin. Chitin is a long-chain polymer, a derivative of glucose, found in many places throughout the natural world. It's in cell walls and exoskeletons of arthropods and crustaceans. Anyway, that's what the keratins are all about. They are the things that protect us from dissolving when we get swimming in chlorine and everything else. They're virtually indestructible. And the same thing around wraps all your is in fascia. Keratins are heavy in the fascia. That protects all of your organs and your muscles and separates them from the other ones. And they're wrapped in fabric bags as well. And I show that in the fascia facilitated fossilization, because the fascia is what protects all of this stuff from being dissolved when it's inside mud, compacted mud. Okay, once again, the petroleum industry. This is different. This is the relationship between the maturity and hydrocarbon generation. How long it's been in the earth, how deep it is, what the pressure is, what the temperature is, all like one big formula. And they know exactly how it works. Different types of kerogens convert to hydrocarbons at different rates, and they yield different quantities of various hydrocarbon phases. And I'm going to show you, I have rocks of all these different phases, from the earliest phases of fossilization down to where they turn into virtual coal. And I can show you these phases in the transition phase and how they sublimate and all that stuff. Anyway, one standard relation between a measurement parameter hydrocarbonization does not exist. So there's they're all over the board. It depends on what the material is and so forth. Values such as vitrinite refractants are generally associated with the onset of generation or indicate the top of the oil window. However, this generally applies only if a source rock is composed of pure type 2 organic material, marine kerogen. The other kerogens and the other terrestrial ones, which is the samples that I have, are all over the board. They are not like a homogeneous mixture, which is what the marine ones are. Algae, virtually. And then it goes down to all these different types: kerogen type maturity, transformation ratios, comparison maturity measurements, closed systems, thermal maturation. I mean, this is all, they know all of this stuff. There's no big mystery here. And it ends up being virtual carbon at the end if it goes through all these sublimation phases and temperatures and depths and heats and all that stuff. And this is known. So I'm showing things that are in the transitional phases. All right, this makes it a little more obvious. This is Van Crevelen diagram, which talks about what types of kerogens produce what kinds of fuels. And it says different kinds of organic matter are more likely to produce oil during thermocatalytic maturation than other types. Algae is the one we're just talking about. That's the where everything drops in. It makes a bed, and it's homogeneous, and it decays and transforms at a pretty consistent rate. No, that's type 1. Hydrogen-rich, oxygen-poor, tends to make good oils. Now, trees and other woody vegetation are made of type 3 organic matter, oxygen-rich, hydrogen-poor, and are sources of coal and gas. And this diagram tells the differentiation between the different types of kerogens. Anyway, again, it's understood stuff. It's kind of technical, but it is understood, and this is exactly what's happening to the specimens that I'm going to show you.